Awesome. Welcome, everyone. Good afternoon. Thanks for joining us for today's webinar. My name is Kaylee Reynolds, and I am a Sierra Nevada Regional Team lead author. Excited to be here with you all as we share the climate projection data for the Sierra Nevada region. This data will be incorporated into the California 5th Climate Change Assessment Sierra Nevada Regional Report. And we are grateful today to have some representatives from the state's 5th assessment team here from the Governor's Office of Land Use and Climate Innovation. We have Aaliyah Becker-Lowe joining us to provide an overview of the work on the assessments to date and the importance of the regional reports. So Aaliyah, thank you for joining us, and I will pass it over to you.
Thank you so much. Hello, everyone. I'm just going to share my screen here. Can you see this okay?
Yes.
Excellent. Wonderful. So I'm so pleased to be here. It's great to see some familiar names on the call. My name's Aaliyah Becker-Lowe, and I manage California's climate change assessment across an interagency team. So today I'm representing these groups, and a few of my colleagues are on the call here today as well. We are so proud to be at this point in the development of the state's 5th climate change assessment, and events like this are really exciting for us to share updates on the process and also to collect some input from communities that these reports are meant to support and serve. So just a little bit of context about California's climate change assessments. This is an interagency-led effort. For the first time, these assessments are led by the Governor's Office of Land Use and Climate Innovation. And we do this in close partnership with 3 other agencies: the Strategic Growth Council, the California Energy Commission, and the Natural Resources Agency. This is defined by new statutory direction that was established in 2020 under Senator Stern, and has really set the course for a new model that is based on this incredible history of past climate assessments that has kind of given us a foundation to build from. So we're so excited to advance that work through these regional reports as one kind of facet of the program. So what are California's climate change assessments? These are we consider the assessments to be a scientific foundation that informs so much of the work that we do across the state, that helps inform our understanding of climate change impacts between now and the end of the century. So they're forward-looking reports that help us unpack those nuances across communities.
I think we lost Aaliyah's connection, but I'm happy to
her.
continue.
Wasn't sure if that was just me, but Aaliyah, are you back?
Did I cut out? Oh, I'm so sorry.
No worries.
Thanks, Emily, for hopping in. So I'm not sure where I left off, but just to acknowledge the very many partnerships that that inform this incredible work. So not only do we get the opportunity to work with academics and other local governments and state agency partners, but the real crux of this work depends on our community engagement and uplifting diverse voices across tribal nations, community-based organizations, representatives throughout all of the state. And this really drives our priorities and helps us set the scope of the work that we do. And so just to give you a sense of the broader portfolio, the entire assessment is built from a suite of climate change projections and various scenarios. We'll talk a little bit about how those are being used in the context of this report today. There's a number of original research products that are underway, some energy reports, some particular technical research that we call the Core Climate Research Portfolio, and a suite of tribally produced research projects as well. All of this helps inform the synthesis reports. So it gets uplifted and repackaged in ways that meet the needs and context of communities across the state. So this Sierra Nevada regional report is going to take a lot of that information and put it in the context of this great region in ways that are meaningful and useful for the communities in these geographies. We also have a suite of statewide reports that are looking at some broad issues of statewide significance. things like racial equity and climate justice, impacts to tribal communities, climate-induced human migration and displacement, and a broad economic analysis, just to name a few of the topics that we're working with. In all, this portfolio is about 60 or so reports. And so we have an incredible body of research that we're excited to roll out in mid-2026. And just to highlight once again our timeline, we are well underway to producing this entire suite of works. Very excited to continue our engagement opportunities, events like this that really guide the process along, and look forward to releasing the complete portfolio mid-year next year. And so today we're going to talk a little bit about this particular regional report, just highlighting a few goals and kind of the foundation of this work that's really driven again in this community-driven process. The intent is to provide actionable science and resources that help inform those plans, those implementation strategies, investment decisions, to provide some consistency across all regions of the state. There's a lot of interconnection between these areas, and to provide resources that are most valuable for the communities that we're serving in these areas. And so I'll just close before passing it off to the author team to share more about the details, with a huge thanks for participating, for your interest, for being part of this. There's not a more important time to take on this work and to help define the priorities that really create a pathway for the research that we're producing, and to uplift all of the perspectives and voices that we really need to understand the impacts of climate change in this great state, and how we can collectively build capacity to be more resilient in the future. So thank you so much for the opportunity to share a little bit about our program, and I'll pass it back to the team.
Awesome. Thanks, Aaliyah. I really appreciate the Governor's Office of Land Use and Climate Innovation joining us today and having your presence here. So thank you. So today we will be walking through the updated climate projections for the Sierra Nevada region. It's my pleasure to introduce our speaker today from our Sierra Nevada author team, Dr. Prakash Kumar Jha, an applied climatologist whose research bridges climate science, agriculture, and hydrology. Dr. Jha is currently an assistant project scientist at the University of California, Division of Agriculture and Natural Resources, based at UC Merced. His work focuses on developing climate resilient strategies for agriculture, integrating climate and hydrological modeling, and advancing decision support tools for farmers and policymakers. Today, Dr. Jha will present climate and hydrological projections for the Sierra Nevada based on CMIP-6 models as part of the California 5th Climate Change Assessment. He's been analyzing the latest model projections to understand emerging trends in climate and hydrology, which will contribute to the regional report. His insights will be invaluable for understanding how future climate scenarios may shape water resources, ecological systems, and impacts on communities in the Sierra Nevada. During the presentation, we're going to please ask that you can stay on mute, and we encourage you to drop questions into the chat. And we will be reserving about 15 minutes at the end just for Q&A, so plenty of time for discussion with Dr. Jha. So with that, I'll pass it over to you, Dr. Jha, for the presentation, and let me get your slides up.
Thank you, Kelly, for the introduction. I hope you all are able to see my slides.
Yes, they look good.
Okay, so I'll talk about climate and hydrology projections for Sierra Nevada region, and I will start from the well-known thing that warming in the future depends on emissions of greenhouse gases and aerosols concentrations. And the thing is, no one knows that what will be the exact amount of greenhouse gases and aerosols in future. So we rely on the assumption and the plausible pathways called the shared socioeconomic pathways in SIM6. And for this purpose, for this purpose of this report, we have taken one high emissions pathway called shared socioeconomic pathway 585, and another moderate emission pathway SSP 4.5. So you can see in this SSP 4.5, the assumption is that by around 2050 the emissions will peak and then it will start declining, and it will continue to decline until the end of century to have the extra radiative forcing of 4.5 watt per meter square by the end of the century. And the high emission scenario pathway is as a shared socioeconomic pathway 585, which assumes that there will be no reduction in emissions and the emission will continue to rise unabated until the end of the century. And the extra radiative forcing will be like 8.5 watt per meter square by the end of the century. So if you remember the last assessment report of IPCC CMIP 5, they have kind of similar pathways. They call it RCPs, which is kind of representative concentration pathway, 4.5, 8.5, 2.6. So if you compare RCP 4.5 with SSP 4.5, you can see like this 4.5 is same. So this is the RCP 4.5 is equivalent to SSP 4.5. The radiative forcing assumption in this RCP was 4.5, which is same as the SSP 4.5. And in SSP 8.5, the RCP 8.5 is equivalent. So the only difference between these RCP and SSP is the socio-economic development, and their evolution, technological development and their evolution. So the first part of, if you see closely, the first part of SSP, this 1, 2, 3, 4, 5, are based on their socio-economic evolution, technological evolution, and policy development. And the second part is the radiative forcing. So I discussed about that because I will be using these two scenarios for climate projections. And now, the second important question is which climate models should we use for climate projection in California? And this is very important because different climate models differ in their magnitudes of warming and the year-to-year variation in warming. So we should select the model which represents climate system or climate process of California better than others. And also, which are more accurate to capture the different, not only the average, but also the extremes. And we have, adopted one study from Kranz et al. 2021, who have compared the climate models for, California and evaluated different, process-based metrics like atmospheric circulation, blocking, extreme precipitation, Santa Ana winds, and ENSO. And they have also evaluated the errors and the skill scores in different ZCMs. And they came to conclusion that these ZCMs are top performing in California. So we use these ZCMs and we use the downscaled version of these their outputs, which is downscaled to 3-kilometer resolution using LOCA2, developed by Scripps Ocean Institute of Oceanography and made available through CalAdapt. We also used another ZCMs as well, which are available in CalAdapt and downscaled to 3-kilometer resolutions. So first, what did we find about the maximum temperature? So you can see here in the left side, we have the average maximum temperature for historical period 1980 to 2009. And you can see there are quite variations in maximum annual temperature within Sierra Nevada, ranging from like 34 to 88 degree Fahrenheit. And on the right side, we have two panels, so which is the average annual maximum temperature, the difference between 2071 to 2100 and the historical period. So this one is the the change in temperature for the SSP to 4.5 scenario, which is kind of the modest emission pathway, and this is the high emission pathway. So you can see, in high emission pathway, it will range from like 7 degree Fahrenheit to 11 degree Fahrenheit. In low emission pathway, it will range from 2 degree Fahrenheit to 7 degree Fahrenheit. And the average annual Tmax and Tmin will increase. This is the aggregated difference for the entire Sierra Nevada by 9 degree Fahrenheit by 2070 to 2099 under SSP 585. And the increase in temperature will be 4 degree Fahrenheit lower under SSP to 4.5. So this is for the these plots are for the maximum annual temperature, and now I will show the same thing for minimum temperature. So you can see the this is the historical temperature minimum for the 1980 to 2009, and the range for minimum temperature vary from 12 degree Fahrenheit to 66 degree Fahrenheit, and you can see there are quite a bit of variations within Sierra Nevada region. So these are the mountains, high mountain regions, and the change, you will be interested about what will be the change. So this is the future, the increase in future temperature for 2071 to 2100 in SSP 4.5 and SSP 8.5. So you can see there are, again, the change, so will be like around 9 degree Fahrenheit, that is the aggregated change, but that doesn't mean that everywhere it will be same. So there are some areas, where the increase is relatively lower, like 7 degree, but there are some areas where the changes are around 11 degree Fahrenheit. So now I will talk about the different region-specific temperature increase, and you can see there are 4 regions here. So like northeastern region, and then northern region, southern region, and then southeastern region. So I'm showing you the plot, which is the aggregated average temperature, minimum, maximum, and average for 2 different periods in historical periods, and then the 2 different periods in future with the 2 different shared socioeconomic pathways, 4.5 and 8.5. So these colors, represent different regions. And you can see, compared to historical period, there will be warming and warming, in every region. And although climate models vary a little bit, this is the mean of the all climate models, and the average warming will be between 9.1 degree Fahrenheit to 9.4 degree Fahrenheit in SSP 585. Now I will talk about another important variable, precipitation. So you can see future changes in precipitation are less certain compared to temperature projection, because in temperature we saw gradual increase, in all models. But in case of precipitation, you can see that some regions in Sierra Nevada, they are expected to become drier than normal, while other regions are expected to become wetter than normal. And if you see the changes are, they are low compared to temperature projection. So this is the percentage change in precipitation. So that is the precipitation during the average precipitation during the last part of the century minus the average precipitation during the historical period, and divide by the historical precipitation into 100, that is the percentage. And the left, this one is the SSP 4.5, and this one is SSP 8.5. So that is calculated for every grid cells. And this one is the historical, so that is the historical normal. So you can see the aggregated, although there are some areas are expected to become drier, other areas are expected to become wetter. The overall aggregated change is increase in precipitation, a slight increase, 11% by 2070 to 2099. And this increase is not very big, but the thing which is important is the shift in intensity and frequency of precipitation events. So there are studies, which show that the atmospheric rivers, which supply most of the precipitation for California, those atmospheric rivers are expected to become more intense in future, and the prolonged dry period are expected to become more frequent. So we should not just look at the average value, but our water management strategy in California should consider those extremes, and we should be ready to adapt for both floods and the prolonged dry periods. Now I will show the region-specific changes in precipitation, just like I showed for temperature. So again, the left two are for two historical periods, and then the SSP 245 middle century and the end of the century, and then for the high emission scenario SSC 585, and these colors represent different regions, 4 different regions in Sierra Nevada. And you can see, in temperature, it was kind of going up, but, in precipitation, there is not much change. Then I want to talk about the snow water equivalent in, April 1st. So it determines the snowpack level in Sierra Nevada, which is very important from the water supply point of view, and also from the, like adapting to floods point of view. So you can see, although the the precipitation is expected to increase a little bit, the snowpack is expected to decline significantly in almost all projections, including those projections which show the increase in precipitation. So by mid-century, you can see only small areas. So here is the mid-century. You can see only small areas will retain historical snowpack levels, except northern Sierra. And by the end of the century, snowpacks are projected to decline by 90% across most of the Sierra Nevada under SSP 585. So these colors, the orange to red colors, they, if you see these colors, that means the snowpack level will decrease, and you can see the value of that decrease in percentage, ranging from 0 to minus 100%. So the question is why we should expect decline in snowpack level, and the reason is because of the increase in rain portion of the precipitation compared to snow, and more snow melting, causing less snow to accumulate and persist for longer periods. So these projections are based on the simulations of from big hydrological models forced by 3 GCMs, and these data are available here in S3 of Amazon AWS. All the another, like the coming hydrological projections are based on these big simulations. Then I want to describe our soil moisture projection. So soil moisture is projected to decline during summer, and the decline is more intense in the SSP 585 than the SSP 4.5. On the other hand, if you see that during winter and spring, the changes in soil moisture will vary. And in SSP 24.5, soil moisture is expected to increase in winter and spring. But if you see SSP 585, soil moisture is expected to increase in winter mostly, but in spring soil moisture is projected to decrease in most locations. Soil moisture is important because the soil moisture, low soil moisture reduces evapotranspiration, increases dry fuel loads, which is which will add susceptibility to wildfires and hence increase chances of wildfire. So the fire weather index is directly related to soil moisture. So if you see fire weather index, it is a function of temperature, relative humidity, and soil moisture. Okay, what about runoff? So here this plot shows the monthly average for historical periods shown by black line, and then future periods for 2071 to 2100. The green line shows the projection for SSP 245, and the red line shows the projection for SSP 585. And these are the monthly averages value for historical and the future. And there are 4 plots you can see. So each plot represents the 4 different regions of. So this is for Northern Sierra Nevada. This one is Northeastern Sierra, and this one is South Sierra, and this is Southeast Sierra. So what you can see here that in future the runoff in winter and spring, here that will increase, but summer runoff after June will decrease in all projections, and the reason is the earlier snow melt and increase in rain portion of precipitation compared to snow, and slight increase in precipitation. And the increase in winter and spring runoff will have implications for frequent and severe flooding and less water available during summer. And this table shows the projected runoff change compared to historical period in different regions of Sierra. In the SSP 245 and SSP 58.5, in overall annual, and then average for January to March, and average for July to September. So you can see the annual total runoff will increase from 88 to 121%. And this plot shows the changes in snow melt in future. There are 3 lines again. Black line showing historical period, green line for future SSP under SSP 24.5, and red line for future SSP 58.5. And this plot is for Northern Sierra. This is for Northeastern Sierra, and this is for Southern Sierra, and this is for Southeastern Sierra. And you can see that by the beginning of June, most of the snowpacks will already be melted. And if you see its comparison with the historical climate, it used to have some snowpack available for summer periods, and that is very important to contribute to the summer stream flow or runoff or soil moisture. But like you can see that in future we will be heading to a situation in which we'll have very little runoff left, little snow melt left for the summer. We also quantified the heat waves, and we quantified, we defined heat waves as the 99th percentiles of historical Tmax, and for every grid cell, we calculated the number of days exceeding that, in both SSP 245 and SSP 585, and you can see this, this plot, for SSP 245. and SSE 585 for 2071 and to 2100. And you can see that, every year, we will have 10 to 20 days, under the SSP 585, when we have temperature maximum exceeding 99th percentile of historical Tmax. So it will become kind of normal, that 99th percentile in future. And this has implications for heat-related illness and, snow melting, evapotranspiration, and wildfire. Then we also quantify the day below 0 degrees Celsius, in future, and we calculated the number of days below 0 degrees Celsius, in future for every degree Celsius, and compared it with the historical climate, and you can see that days below 0 degrees Celsius will significantly decrease in future. And this has implication for snow accumulation and snow melting. And that's all from my side. I would expect more questions and clarifications on this presentation. Thank you.
Thanks, Dr. Jha. Appreciate your presentation. Really fascinating and maybe not so lighthearted, but appreciate you giving us that insight. And we can open up for Q&A. So feel free, anyone in the audience, feel free. You can just unmute yourself if you want. You can jump into the chat, use the raise your hand function, but I think we can be pretty informal. So feel free to just come off mute.
Thank you for the talk. Oh, sorry.
No, you go ahead, Isabel.
Thank you for your talk. Is there any reason why you selected historical data as a 1950 and 79, and second historical data was 1980 and 2014?
Yes, we want to see the changes for longer time frame, and also small like the 30-year time frame. So and we also want to be consistent with the fourth assessment. So in the fourth assessment, we have similar periods. So we can compare the changes of this fifth assessment with the fourth assessment.
Thank you.
So this Mike Dettinger. So as to the heat wave, the last slide or the last couple slides where you had the heat waves, I just wanted to comment that, and this might be old news, but for each county has got a public health report associated with it that provides a local heat wave threshold that they feel that the public health folks felt was where you got to levels that were a public health issue. It occurs to me that you might, if you haven't looked at those, you might want to, in order to there might be some way of masking your 99th percentile heat waves map with something that gives an indication of sort of where you're getting into that range. For a lot of the lower stuff, you'll be past that very often, and among many of your days there. But as you get higher and higher, then we get into a situation where the public health data doesn't tell us that there's a big problem. And I'm not saying there isn't a big problem. I'm just saying the public health data doesn't, say, at 10,000 feet, 60 degrees is a heat wave or something like that, So anyway, you might look at that if you haven't, because there might be a way of sort of masking things to sort of call out the public health side of it. You listed several impacts of heat waves, but you might be able to call out some of the public health issues in the process.
Thank you, Mike. Yeah, I'll definitely look at the public health county specific data related to heat waves and their implications.
Yeah. Thank you. Nice stuff, by the way.
Hi, Prakash. Thank you so much for the presentation. My name is Joe Harvey from Tahoe Conservancy. I'm probably going to be the one asking the dumb question, and I'm not sure if you can answer this. But with our current, the two different models we've been looking at, the SSP2 and the SSP5, correlating to the RCP 4.5 and 8.5, is there still any hope we can achieve the SSP2? Or is our current trajectory pretty much setting us on that worst case scenario? Thank you.
Yeah, I mean, if you ask me, whether we will be able to go through that SSP 2.5, I mean, that is very tough question. So, it depends on the global negotiations on the climate mitigation. And currently, we are not heading on that pathway. So, we are heading toward the worst case pathway. But it can happen. There is still hope for 4.5. Because we are not we are not like very far away. So we still have time for that.
Helene, go ahead.
Could I come in on just one thing? Okay. So for the longest time, Joe, we were on the basically the 8.5 path with what we were actually emitting into the atmosphere. But COVID knocked us off to a point where the last 10 or 20, something relatively long period, let's say last decade, as it happens, it dropped us onto the 4.5 curve, okay, for where we are at, by 2025, that sort of thing. And my point isn't that, my point is that it takes something like COVID to make the difference at this point between the two. And so, we can be really depressed and all that, but it actually, we've seen that it's easy within a single year, quite frankly, under that extreme condition to bump between the two. So I always say, do not concede 8.5, okay? I really don't think we should be conceding 8.5.
Thank you very much, both Mike and Prakash.
Yeah, we always, hope for the best, but we should also be ready for the worst. That's why.
Yeah, no doubt.
Yeah.
Yeah.
So, hi. So this is Helene Margolis. I'm CLA for the Sacramento Valley Region report, and so I have two questions actually. One is, when you go from mid-century projections, let's say to the high, what you're showing, which is end of century, is it linear or non-linear in your models? So, so is it a linear relation from historical, and then we get to the projections for mid-century, and then when we go from mid-century, and let's just assume worst case scenario, or perhaps those two different scenarios vary in whether they're linear or non-linear, just so that we get a sense of, do we have, let's say from a heat illness perspective, do we have a chance in mid-century and all bets are off once we get to end century?
Yeah, that's very interesting. And, that will be worth analyzing. But, in this presentation, if you see, and I haven't analyzed that, but, if you see that SSP 2.2, 4.5 and SSP 8.5 comparison for heat waves or freezing, you can see, it is not linear. It is kind of, more exponential. And I can show you again if you want, but, there is no analysis of trend. So,
and
it might not be.
Oops, sorry.
So can you, go ahead, please.
No, it was just really the, so this is the heat waves, but I'm just saying, even in terms of the if we're looking at the average temperatures,
Uh-huh.
or in general, any of these projections for temperature, and then perhaps even for the precipitation, which I realize is more complex in the modeling.
Uh-huh.
But
Yeah.
in terms of if we were to look at, let's say, adaptation mid-century, and we're saying, okay, these are the thresholds above which, you know, we really have to up the healthcare system preparedness. And then we can maybe project out to end of century. But if in fact it's nonlinear, if it's exponential in terms of these changes, the whole adaptive capacity assessment changes.
Right.
So I'm just putting it out there as a sort of, you know, whether this has been evaluated in terms of that relationship between the projections for mid-century versus end of century. And then the other question, which is not totally related, but is in some ways, is for your mid-level elevations. So in your higher or even the lower elevations for your foothills, how is the precipitation going to play out in terms of the groundwater? So I was thinking in terms of like, and this actually is something I'm grappling with in our area, is how the orographic shift, you know, if the temperature's rising as we go up slope, and where is that orographic, you know, threshold where we're suddenly getting a whole lot of precipitation higher up, but then those lower levels where a lot of people live, they're going to have groundwater shortages. So I'm wondering if you've, you know, across your very large region, whether you've looked at that.
Yeah, and that is really, you know, like very important. You know, I can do that. All I have to do is like to include a topo map and see the the aggregated change according to altitude. So that would be worth analyzing, and I think like I will do that.
Okay.
Yeah.
And I have a couple of really, you know, excellent climate scientists also on my team. So we'll coordinate at some point and compare
That would be
notes.
great. Yeah, that
But
would be great. Yeah.
okay, thanks. Thank you for both answers.
Mhm. Thank you.
Isabel?
So actually, I was gonna follow up on Helena's comment. I think is where the precipitation, maybe one thing that is worth looking is, so you want to know how the snowfall is changing, because that is going to come downhill, like groundwater. So it's not just the precipitation in the lower hill. It's like how much the snowpack is going to change, because that's key to providing. So precipitation is one thing, but really what people rely, especially after, is like a lot, especially in California, that makes a big difference. So just looking at that, which is slightly different than looking how the precipitation are changing, and is even harder to identify.
Yep, point taken.
Mhm.
We still have some time, so if anyone else has any more questions, we can take those. And I will just note that we will be sharing the slides and this recording with everyone. So sorry, do you want to?
I have a question, sorry. What are the observations data are you using, and what are the resolutions for the historical data?
I am not using any observation here. These are all model projections.
Model
So
predictions.
even for historical, that with the historical projections.
Got it. Thank you.
Yeah, and the resolution is 3 kilometer. They are downscaled by the LOCA 2 from Scripps Institute of Oceanography, and that is available in CalAdapt. So you can download it directly at 3 kilometer resolution.
Thank you.
And the hydrological projections, they are from the BIC model, and they are available in the AWS of Amazon in S3. So you can directly, download from there and analyze.
Thank you.
In the initial slides that you showed, the initial slide, I had a question about whether you include some sort of estimate of volcanic eruptions, historical, and I don't know how you would do a future projection, but I mean, somehow, there's greenhouse gases added to the atmosphere that are way beyond our control. So just kind of see if you've included something in there in the analysis for that.
Okay, I can do that. I mean, but bear in mind that volcanic projections and their impact on climate is just short term. So in long term, they will not play a major role in long term trend.
So the mic again. I'm not sure whether I can get away with this. So let me just say that in the sense that I made one comment in the notes in the chat, and then I made a comment earlier, and then I made the comment about the recent emissions on vocally, and I just I'm thinking I would like to drop 2 slides into the chat and hope that somebody there will make sure to grab them. They both have I believe they both have references associated with them, so you can just they're a resource. I'm not saying we look at them now, but they basically are places to look for a little bit more on my 2 comments. Okay. So anyway, I'm gonna drop it. We'll see if this works.
Yeah, Mike, if drop them in the chat, but if for some reason it doesn't share through the chat, you can also email me them directly.
Okay. Looks like I'm gonna have to do that. So I'll just email that at you. Sorry to interrupt with that. I just don't like to say things to you guys when you're writing and stuff if I'm not gonna at least give you a resource to draw on. So
Yeah, that's great. Thank you. And if there are any more questions, we can get to those now. Okay, we might be coming to a close here. So thank you, Dr. Jha, for your presentation and your expertise. Really appreciate you sharing that with all of us here. And thank you for all of you joining us today. Like I said, we will be sharing the recording and the slides out, and you can always reach out to our team for any additional questions or to connect on any other resources like Mike was saying. So feel free to reach out, and we will be in touch in the next few days with the resources. Thank you so much for joining us.
Thank you.
Thank you, all the participants. Thank you.
Thank you.
Bye.
Bye.
Mm.